Okay, so today is our second discussion on lighting. We're going to be talking about still life lighting, lighting more than one object with more than one light in certain cases. We do have two different still lifes you guys can choose from. One is an actual still life of an object. It's called the Cornell Rabbit from Cornell University. It represents one of the first point cloud scans that were done in our industry. If you're not familiar with Cornell, they were one of the pioneering universities in 3D research. So they did a lot of firsts. They did a lot of radiosity tests, which is where color transfers from one surface to another when you render and you have reflectivity. They also pioneered a lot of cloud scanning. So if you choose to do the rabbit, you'll notice it's triangulated. It's very dense mesh. That's because all those points were then transferred into polygons. So in order to make sense out of it, it had to be a pretty dense mesh. But it does serve its purpose as far as being a subject for still life lighting or portraiture. We do have an actual still life, which is a small environment, cup, candle, bowl of fruit, the usual kind of stuff. That gives you a chance to practice with multiple objects. So you want to download Project 3 SAL-C zip. That will contain all the stuff you guys need for today. A couple of quick notes. The only open lab that was canceled so far this month is the 17th. That's because Hall of Fame is taking place that week, and the room that we originally had reserved for open labs, they took for a classroom. So everything else should be good. Next Friday will be the first open lab I'll be able to run for you guys. So pop in if you have a chance. Normal office hours will be from basically 10 to 4 on Wednesdays and Fridays. All right, so we're going to talk about soft lighting. In particular, the mental ray area light. That is where we start to use a light that is more physically accurate than the Maya version. Remember, mental ray was originally built for the architectural community. So when you're doing architectural visualization, that makes a huge difference. Yes? Go to training is not showing my screen. Good, thank you for letting me know that. Go back and fix that. There we go. Should pop in a second. All right, good. All right, so whatever I said earlier, blah, 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 blah. There's a picture. Blah, 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 blah. Open labs. There's another picture. And we're here. All right, so the mental ray area light, as I started to say, was built for physical accuracy, a lot more than Maya. Maya is just a physical light, meaning you can scale it. You can make it smaller. If you scale it, the shadows get softer. If you make it smaller, the light acts like a hard light. Whereas with mental ray, it actually creates a lot more light that wraps around a subject. So mental ray, created for the architectural community, trying to be as physically accurate as possible with materials, with the way it renders, and with the way it handles light. As you guys get further down the program, you switch over to Arnold, or you switch over to RenderMan, or V-Ray, or whatever it happens to be, you'll know that they all have their own versions of lights. In fact, in Maya 2017, Maya's lights are not recognized in Arnold or in RenderMan. Put a Maya light in there, nothing happens. Funny thing is, you can use Maya materials with a RenderMan light or an Arnold light, and it will recognize the material, but it will not deal with the light. That's because each renderer handles physics a little bit differently. It's got its own bit of code in there, its own algorithm to handle the way light rays are supposed to bounce. So instead of trying to retrofit something very old into something new, they just decided, you know what? The materials we can deal with because that just deals with how objects reflect light back. But the light itself is a big deal. So they just went ahead and pretty much shut it down. So you have to use whatever renderer, their version of the light. And it's really not that big a deal. They all have the same thing. They have area lights. They have directional lights. They have point lights. They have spotlights. They may be named a little bit differently, like directional light, sometimes called an infinite light, or they may just call it the sun. But it still behaves the same way. So if you understand the basic principles, you'll go far with that. All right, we're going to also deal with light linking. This is where we can link specific lights to specific pieces of geometry. This is really good when you're dealing with multiple lights. Because a lot of times if you have a rim light, you may have that rim light hit geometry or a surface you don't want to hit. You don't want a shadow to be cast because it detracts from your still light. Yes?
It's kind of like having multiple shadows on one object, because like you say that you have like multiple lights hitting one thing, and it kind of makes different shadows.
Yeah, it's kind of like that, although what we can do in Maya that we can't do in the real world is we can turn shadows off. So if we want the light, that's fine. But if that light casts a reflection or it casts a shadow where we don't want it, that's where we'd unlink it. But multiple shadows, if we have to, we will turn shadows off. In fact, I'll give you some pointers and some tips for dealing with the rabbit if you guys decide you do it. Because there are some tricks we can do that you can't do in the real world. We're also going to talk a little bit about final gathering. Final gathering and using some very simple image-based lighting. Image-based lighting for us today is basically going to be just a sphere with a color in it. And that will help contribute some extra indirect light in our environment. Until now, we've been dealing with it kind of on a secondary basis. But this is going to become part of your lighting palette. Whenever you start lighting, you're going to make sure final gathering is turned on, then you're going to start lighting. Because you want all that secondary indirect contribution to be calculated from the very beginning. Same thing when you guys get into global illumination with more advanced renderers. Global illumination, for the most part, in real advanced renderers, is on by default. And it's just there and it works. Whereas, since mental ray is kind of in a little bit of an older version, we have to turn stuff off and on. And we're using final gathering as kind of a stepping stone between no global illumination and full tilt global illumination, which is really just starting to get really good. They've been working on it for 15 years. And finally, it's getting to the point where it's ready for prime time without killer render times. And that was the trouble with global illumination. It had to calculate rays everywhere, and it just took forever to run. All right, so let's do a little review. And this will act as kind of a really good chart for you guys to be able to have and utilize. Now, let me turn off some of the glare. Right, so let's start with the directional light. What is the shadow softness control for the directional light? Check your notes. Launch Maya if you have to. I don't expect you to remember all these things, but you should be able to know where to look for the answer in a fairly quick amount of time. By default, you're going to get hard edge shadows with the sun.
Is it light angle?
It is light angle. Very good. Light angle. That is representative of where the sun sits in the sky for us. So with a light angle of 0, it acts like the sun at noon. What is the quality control? How do you clean up the edges of that softer shadow now? Because it's going to look noisy. Gritty.
Shadow rays.
Shadow rays, yes. The default number for shadow rays is what? 1. Uno, 1. Right. when you have a single ray shooting from a surface point to a light, okay, that cannot cover a lot of area, right? Straight line. So it's only going to be covering that very small pixel that it takes up. Whereas if you've got multiple rays shooting out of a point, they can spread out and they can start to crisscross, and that's where you will get a cleaner looking shadow. Okay, how about the spotlight? What is the shadow softness for a spotlight? You're not sure? The spotlight?
Drop
Yes.
off.
The number up?
Okay, here's a way to tell if it's a shadow control or a light control. If it's under the shadows attribute, it's a shadow control. If it's under the top section of the light, that's a light attribute. That would be light itself and not shadow. Yes, yes, light radius. Light radius, because our spotlight starts off light as a point in space. But instead of illuminating in all directions, we focus that point of light through the cone. So it projects. So light radius, absolutely. How about quality for that spotlight? You guys should be jumping all over this one. What is it? Shadow rays, yes. Shadow rays. Okay, Maya area light. How do we make that softer? If we make an area light, you go down under shadows. Yes, you make it physically bigger. It's scale. You make it bigger, it's a softer light. You scale it inwards, it becomes a harder light, and the shadows become harder edged. So scale, physical size. All right, how about the quality of the shadow? Shadow rays, yes, everybody should be screaming that out. Shadow rays. Notice a common theme here. Shadow rays. All right, point light. How do we make that light softer? The shadow softer, I should say. Light radius, yes. Remember, it shares a lot of attributes with the spotlight. They start off life together as a point in space. Mathematically, infinitely small point. Okay, shadow quality? Shadow rays, yes. All right, so that's kind of a good chart that you guys should have etched in your brain. Nothing else. Quality should be an easy get. All right, shadow rays, pretty much for every light. If it's a directional light, it's going to be light angle. Think of the sun, based on the angle of the sun in the sky. If it's a point light or a spotlight, it's going to be physical size. It's going to be a radius, not a physical size, sorry. It's going to be a radius because it starts off as an infinitely small point. The only one that we control physically is the Maya area light so far. All right, any questions about that? Anything not clear about those? Because we're going to be using this kind of information throughout the whole month. It's one of the foundation things. All right, so hard light versus soft light. Same object, same camera, same exposure. The only difference was the light on the right is a spotlight that I used to photograph this. On the left I took that spotlight and placed a hood over it, called a softbox, and that diffused the light. It made it into, for want of a better term, an area light. This is the kind of light I use. Basically a spotlight, put a hood over it, it's got this really nice diffuser in the front. This shape is equivalent to our what? Area light, yep. That's exactly what the area light is trying to simulate. Something like this. Now, photographers use this because it not only makes the light soft, but it also gives it a really nice broad area to reflect when you deal with reflectivity. Right now, we're not dealing with reflectivity, but in the future, that will make a difference. It's the shapes that we see in our reflections that tell us, through years of observation, what we're looking at. Anytime you see any kind of car commercial on TV and they're in one of those big warehouses, you can bet they've got a ton of these. Big thing that they like to do for cars is they have a ring of material that's like this on the ceiling, and they put lights above it. They put a big ring over the car so it shows the lines of the car all around the top part. They'll also take parachute material, throw some really bright spotlights on it, make the whole parachute material light up, and it gives something nice to reflect. And basically, they're just interested in shapes. Anything that helps to define the form. Whether it's a car, whether it's a piece of fruit, whether it's glass. You'll see this kind of stuff in any kind of perfume or anything dealing with glass on TV, in magazines, product shoots. Because that kind of shape helps to tell us what we're looking at. All right, so a couple of things you can observe from hard light, which is the spotlight versus soft light. It's kind of hard to see on the crappy projector, but hopefully it comes through a little bit better in Go to Training. This area right here, you can see some surface detail on top of the drive. It looks rough. It looks bumpy. It does not look smooth. Right? The front part looks nice and smooth. The top part doesn't. You can make out the logo pretty good. Why? Because direct light creates a harder shadow. So it goes across the top of the surface, creating some small shadowy areas that help us to define the surface. Whereas with a soft light, you can barely make out the material that's on the top of the drive. This is good and bad. It's good if you're trying to do a portrait because it tends to hide blemishes. If you guys ever see those, what is that real popular acne medicine, Proactive or? Yeah. All right. They always show you before and after pictures. Well, the before pictures are usually done with hard light. And they make people look like they've got caverns in their face, and it looks like road maps. All right. When they're done, they put a little bit of makeup on, put a soft light on, and smooths everything out, and it looks miraculous. All right. Soft lighting, it surrounds the subject. It tends to even things out. That's why a lot of shows that have interviews like Ellen or any other interview show you can think of, right? They have a lot of lights all around, and they're usually soft that are on the subjects. That's to make them look good. Now, if you're doing a product shoot, you want to sell something, which one are you going to use? Yeah, probably the one on the right, because you can see the name, you can see the surface. It looks relatively clean here. Kind of looks like it's, for some reason it looks older because it's washed out. And it's a brand new drive. All right, so just a couple of quick examples of soft light versus hard light in the real world. When we get into materials more, we're going to be dealing with different surfaces, different surface qualities. You're really going to be able to see it come through at that time. All right, soft lighting in cinema. This is unlike film noir, where The lighting is actually part of the story. It's part of the visual. Soft lighting in film, in games, in TV, not meant to draw attention to itself. It's not meant to get in your face. It's just meant to support what's going on. One of the key words you can use to describe soft lighting is a gradient. It's a nice, even transition between dark and light or light and dark. Whereas with hard light, you usually see an abrupt change. In CG, without soft lighting, we would not be creating believable environments or believable stories. We have to create something the audience can relate to. We're used to dealing with our physical world all the time, and it's good to have things stylized, it's good to have, fantastical environments, but if we can't relate them in some way to our world, generally you don't have as much support from the audience. All right, got a couple great resources for you guys inside Lesson 3 today. One is this compass. Very simple, you would think it's common sense, but this is all based on camera being in the front. You can move the camera to any position and this would just rotate around. All right, so you'll notice that a lot of common things that you see in photography, in games, in film, a lot is going to be based on this first 180 degrees. You're going to have a lot of lighting coming from, 45 degrees left or 45 degrees right, somewhere in there, that 90-degree radius. Why? Because it helps to define the form. If we light straight on, what did you guys notice with front lighting? What happens? Nobody did. Everybody must have done at least one front light.
It made it 2D.
Yeah, it made it flat. 2D is a good definition. We tend to lose depth. It flattens it out. Foreground, background, they sort of come together almost. Whereas when you become off center from where the camera is, then you start to bring a little bit of depth in. Because now you can see shadow, the way shadow falls. Does shadow hit the background? If it doesn't, where is it? Somewhere in there. Right? You also have side lighting. And then we have either rim or backlighting in the other 180 spectrum up top. So usually rim lighting, some backlighting will come from 135 left, 135 right, all within that 90-degree radius. True backlighting or silhouettes probably going to come 180 degrees from where the camera is, because you want to put your subject in complete darkness. You want to be able to illuminate the back, but not the front. All right, so you can download that. There's a link that will take you right to the reading that has that in there. Now, another great resource is this Digital Camera World Portrait Reference. All right, so there, you can go right there, light direction, lighting compass, digital photography. Right, so down here under extra resources, free portrait guide. It's got 24 studio lighting setups. Today, after you guys do one of the still lifes we gave you, you're then going to choose, and I would encourage you to choose one of the multiple light setups from this guide and try your hand at doing a portrait of either the rabbit or an object or two from the still life. Practice the lighting positions. Now, couple of things that you guys need to know for the Chrome users. Not really sure why, but when you open this up, sometimes it does not open up to the free portrait lighting guide. No idea why Google does that. but try it with either Firefox or Safari. So, once you get to the page, this is actually not the guide. The guide's down here further. Once this loads, click on it. It's a big, giant JPEG. So once you get it to this point, you want to right-click and download it. And I'm going to get out of here just to save some bandwidth for you guys because I've already got it downloaded. So this is what it looks like. This is actual size. So they give you breakdowns. This is something if you want to practice lighting, go to any photography website and they will usually give you breakdown guides and lighting guides like this. They'll tell you exactly what they're using. All right, anytime you see the word strobe, that usually means some kind of bright light, usually a flash. Strobe usually means it goes off. It goes on, it goes off with the camera shutter. One stand, 20-inch softbox. That means they're using a single, what kind of light would we use in CG for a softbox? Area light. So they're using basically an area light. Now, this is called Rembrandt because Rembrandt always dealt with a lot of light and shadow. You notice a lot of his paintings, that was a very typical look that he developed. And photographers love that look, and they actually have a whole bunch of different lighting kits and setups that mimic the way his paintings look. So, in the real world, our area light hits the subject. It also hits the backdrop. Does a pretty good job of bouncing around and illuminating our subject. A little bit like film noir. In fact, film noir got some of its starting points from the Rembrandt look. All right, so you can see down here, one strobe, that's basically a spotlight. Light stand. This is called one white shoot-through brolly. It's basically an umbrella that allows light to go through it, but also bounces light behind it. All right, very similar look. Gets a little more light on the subject in the back because it tends to bloom out a little bit more. All right, the one on the far right here, not far right, this would be one spotlight, and that's it. Aimed at the subject with a very narrow cone. How do you know it's a narrow cone? Because they show you with a picture. Notice the light does not hit the backdrop. It's focused in on the face. High contrast or low contrast? High contrast, yeah. Light, dark, nothing in between, basically. Very little gray. All right, so a lot of different looks here. What really gets interesting for us, these are all single light setups. They're just basically showing you different positions of the subject, different positions of the light. This split with a fill, this would be one of the ones that you could use if you wanted to practice. Why? Because this technically is more than one light. You've got a key light, you've got a bounce card. For us, a bounce card is going to be another area light. It's going to act like a fill light, a lot less power. All right, camera shooting right from the center. So that looks like a standard 2-point lighting. Key light, fill light. All right, so we have some more single lights. Again, they're all kind of theme and variation. All right, when we start to get down here, flat light. There's another one. Flat light meant to illuminate the face. But the difference between straight ahead front lighting than flat lighting is we've got light on either side of the face. So it creates a brighter spot in the center and gradually less intense toward the edges. So it doesn't front light the whole face, making everything look even. Plus, the backdrop, by default, is going to start to get darker. Right, the badger. Everybody usually likes this because it kind of looks very mysterious. Right, creates that kind of V look in the front of the face, typical of what a badger has on its fur. Right, one thing you have to be careful of, make sure your lights come around to the side so that they get the effect. You just can't go on position here because this is real world lighting. We get a lot of extra bounce light, a lot of extra wrap. But in CG, we're interested in creating it rather than mimicking what we see there. So that is a good starting point, but you're going to have to move stuff around. Okay, again, 2 soft boxes, 2 area lights. Right, clamshell, it's basically one light on top of the other. Here, the next one, this one would be, anything with more than one light would be acceptable, or a light and a bounce card. All right, so here we have, what kind of light would this be? This one right here. Area light, what would this be?
Spotlight.
Spotlight, yep, exactly. Notice that it's a small spotlight focused behind the subject. Again, that's how we're separating. We're not aiming it at the subject, we're using it on the backdrop as kind of a nice little bright area, again, separation between subject and background. Here, area light in the same position, but this time, swing the light around so that it hits the back of the subject. Rim light. High key. Now, we've got a lot of illumination. High key generally means everything is illuminated. Early television sitcoms were all lit like this. I don't know why, but they were. All right, so you've got almost identical area light. You've got an identical spotlight in the back, but this time you've got a reflector. That reflector is also shooting light onto the backdrop. All right, so again, got different kinds of theme and variation. This one at the end, colored gels. In photography, we don't change the light bulb with a different color. We throw what's called a gel or a translucent looking plastic material in front of the light. The reason it's called gel is because in theory it doesn't burst into flames with the heat. Because some of the lights are very, very bright. Smaller lights are 2,000 watts. They go 5K, which is 5,000 watts, they go 10K. That will set stuff on fire. If you ever work for a photographer or work on a film set, they will yell out, lights going hot. That means don't look. Because the first thing you do is look. And okay, burn your retinas out. You'll be on the sidelines for about 40 minutes. Gone. I see a black hole. All right. So this, they put gels in front, but in CG, do we need to use gels? Now, what do? Change the color of the light. See, it's so easy. You don't have to burn your fingers. You don't have to get blinded. So simple. So easy. It's not like you have to pick up a 75-pound light and move it over 3 inches. You can just go. All right, but this is a lot of fun to play around with because they're playing around with different colors. Remember, cool colors do what? Come on, I'm sure you've had this drilled into your head. Do they recede or come forward? Recede, right? Cool colors recede. Warm colors come forward. And that's exactly what they're trying to do. Now, of course, your job is to, in the beginning, not make it look too much like a clown nightmare. Because it's real easy to make the lights way too saturated, the intensity way too bright. But that's all part of learning. All right, so take a look at this guide. I highly recommend using one of the multi-light setups as your reference for the comp you try to make on your own. It's real good practice. It's good stuff. You're free to get whatever you want, but the reason this is good is because they give you the lighting diagram and breakdown. So you got an idea where to start. But you're free to, if you wanted to pull something off the internet and try and mimic a shot that you've always loved, go for it. But in your mind, break it down. Take a piece of paper, sketch it out. Where's my main shadow coming from? That's your key light. Does it have rim light? Does it have backlight? Does it have fill light? All that stuff you need to be able to diagram and understand where it's coming from. All right, so any questions so far? All right, so these are the two scenes you guys can play around with. There's the Cornell rabbit on the left, still life on the right. They all deal with more or less the same kind of thing. Key light, fill light. The rabbit has a rim light. This does not have a rim light. This has a backlight. Is the backlight aimed at the backdrop or the still life? Backdrop, yes. We're creating that little kind of nice little halo behind it. Again, just to separate subject from background. Again, common photographic practices. I'll go over the rabbit a little more later on. Frank will also break it down for you more in lab. But a couple things to note. Which direction is the key light coming from? From the right side. Why? Because this is bright. That is not. So if key light's coming from the right, where's your fill light going to come from? Probably the left, absolutely. You can tell, not nearly as bright as the key. And then we've got a rim light to separate his cute little evilness from the background. Now, something else you're going to notice when you start playing around with this. All right, I've got a key light, fill light, I've got a rim light. My rim light is actually not casting a shadow from the rabbit. It's not even registering on the backdrop. That is because we unlinked the rim light from the backdrop. We only want it on the rabbit. So there's one instance of light linking. Here, you may need the same thing because your backlight may be hitting the fruit depending on where you position the light, and it may cause some issues. So you can unlink it from the fruit and only link it to the backdrop. Again, you can do it with and without light linking on this one. This one, you cannot. Another thing you'll notice with the rabbit. Got a nice rim here, but there's some magic light coming here on the back part of the knee and on the foot. That's coming from the fact that the rim light has the shadow turned off. Because normally, when light hits the rabbit would self-shadow. But if you turn off shadows in the light, it will allow any light to bypass that and keep going. So there's a hint as to how you get that little kind of kick light here on the knee and on the foot. And the rim light's the only one you turn shadows off. It's a very rare instance when we don't want shadows, but it's usually on something like this. It's usually a rim light and not one of the main lights that we're using. Right, so we're going to be doing all the same stuff, like direction, light intensity, light color. Contrast is going to be your shadows. Contrast, hardness, it's all about shadow quality. We're going to give you breakdowns for each light. That means we've got reference for just the key, reference for just the fill, reference for just the rim or the back, depending on which scene you do. Right, so that's going to be the lion's share of the grade and your exercise, because dealing with more than one light is going to take more time. Then you guys are going to work on finding your own reference. Like I said, I highly encourage you to use that portrait guide. And what you can do in the portrait guide is very simply open it up in Photoshop, find the one you want, and I don't want that one. I want the badger. And crop it out in Photoshop, and that's what you'll put in your reference. Don't take just the picture, take the whole guide setup also. Plenty of room in the reference area at the top for that. Now, one of the big things about today is we're going to be using mental ray area light. And from this point forward, anytime you guys see the word area light, automatically assume it's going to be a mental ray area light. We are graduating from the Maya playground into the real world of more physically accurate lights. So mental ray area light is a given. All right, so again, light position, elevation, how high up is the light? That's going to be determining a lot. Elevation, rotation. Light position, is it on the side, is it on the front, is it on the top, is it in the back? That's going to be pretty simple. We're giving you lighting breakdowns for them. All right, so this elucid mental ray area light that I speak of, very simple. It starts off light as a Maya area light. As long as you have mental ray loaded, you're using it to render. In the light attributes, you go down past shadows to a mental ray section. Expand it. There's an area light sub-attribute. Turn on use light shape, and you have made your first mental ray area light. High fives all around. Yeah. Fist bump. Very simple. That automatically disables shadow rays. Once you turn an area light into a mental ray area light, shadow rays no longer clean up noise. All noise is cleaned up from this very simple area here called high samples. High samples, high samples, high samples. Why am I repeating it? High samples. It's important. High samples. All right, you see high sample limit, low samples? That only deals with reflectivity. Right now, we're not dealing with reflective surfaces or transparent surfaces. So you could change this. It'll increase your render time, but you won't get any benefit. This is the one. Like most things mental ray, it starts off life with 8 samples. That means each surface point shoots out 8 rays to the light. And if you've got an area light, right, one surface point, that means you can cover a bigger area than you can with one. But if you've got an area light this size and a very teeny tiny little point right here, if you spread 8 rays out between a big surface like this, you can't possibly fill in all the gaps. So what does that mean? You get a noisy shadow. All you do is increase high samples. How much do you increase it? Double it. Go to 16, go to 32, go to 64. Whatever number cleans it up for you. Mental ray area lights, there will be times when you approach triple digits. Actually, you will be in triple digits sometimes. It can be expensive. If you've got a whole environment filled with these, then you're going to have a pretty expensive render. But they are going to look really nice. So just remember, when you're trying to recreate physically accurate things, it's not cheap. Free and good are generally not the same. If it's free, it's usually okay and below. Anytime you have to pay for something, you're paying money, you expect higher quality, higher performance, a better product. That's what we're using here. All right, I'll give you a demo with that light. I'll compare the two, Maya area light to a mental ray area light. Really not that difficult to use. There are some extra bonus things that the mental ray area light can do that Maya can't. You can change the shape of it. You can also make it visible to the camera. Those are big deals. Okay, light linking. How we unlink lights from specific pieces of geometry. That is found in the relationship editor. You're going to go to Windows, Relationship Editors, down to light linking. You've got a choice. You can do light-centric or object-centric. All that's going to do is pull up a dual kind of outliner-looking window like this. Light-centric means your lights are going to be on the left side. If you select a light, it will highlight all the geometry that's associated or it's linked to. By default, when you create a brand new surface in Maya, what material is assigned to it? Lambert. Also, when you create a new surface in Maya, every single light in your scene is automatically linked up to it. Anytime you create a new light, it's automatically linked up to every piece of geometry. That's good. You generally want that until you don't. To unlink something, for example, 3 lights here, actually 2. Got a spotlight. If I want to unlink it from the backdrop, I find the backdrop in the list, unhighlight it, just left click on it, and it will break the connection. This is why Maya 2016 Service Pack 6 is important. Anything Service Pack 4 and below, light linking is broken. Or it'll work sometimes and not others. This is usually how computers get broken. All right. If you want to link it up again, select your light, left click on the surface again, it'll highlight it, it'll be linked back up. Object-centric, which is your other choice, the only difference is geometry shows up here, click a piece of geometry, it'll highlight all the lights. Either way works, depending on how you want it to work or how you think about it. But it will get you the same results. All right, I'll give you a demo on that too. That's actually pretty simple. Any questions so far? Okay, final gathering. Final gathering calculates what we like to consider indirect illumination. But really, what final gathering does is it calculates color and value information from surfaces. So if your surface is very dark, like this, it's got low value, final gathering is not going to contribute a whole lot into your scene if everything is black. I hope there are no rats that live in here. Likewise, if you've got something light and bright, like this has high value, around 1. Final gathering can definitely grab information from this. Color, value information, this will contribute a lot more into your scene. How does final gathering work? Final gathering will shoot points out from your camera into your scene. Why the camera? Because it doesn't care with what the camera can't see. It only cares about what's visible. So it shoots points out, kind of like a scatter, shoot, paintball effect. Imagine those points are all little splotches all over the place. The next thing it does is each point shoots out rays. Those rays are called accuracy. The points are called point density. By default, your point density is going to be 1.0. That's not 1, it's not 100, it's not 1,000, it's not 1,000,000. It's based off how much geometry is in your scene, the field of view the camera has. It makes a decision how many points to shoot out. Now, if you turn that number up, obviously it will shoot more points out. If you turn it down, it will shoot less points out. But they chose this number because it is a good average number. So each point in your scene shoots out rays. Those rays are called accuracy, and by default, each point shoots out 200 rays in different directions. Now, those rays hit a surface, and they come back with information. So, for example, there's my point. There's another point. So, final gathering is going to shoot out 200 rays. It's going to hit the ceiling. It's going to hit the back wall. It's going to hit you. It's going to hit the table. It's going to hit the floor. It's going to hit me. Whenever it hits, it's going to come back with color and value information. So if it hits the ceiling, what's it going to get? First off, what color is it? Kind of white. Hard to tell. It's in shadow, so it's going to read it like it is. It's probably going to be some kind of light gray. That's going to come back with light gray information. It's going to hit the back wall. What color is the back wall? Kind of yellowy gold. Right? Depending on where it hits, if it hits near the ceiling, it's going to have more value in it. If it hits closer to the floor, it's going to have less value. But it's also pretty far away. It's going to hit the floor, it's going to hit you. So it's going to come back with all that information. All right, same thing with my blue point here. It's going to shoot out, it's going to come back with all kinds of different information. So all those points are coming back with all different kinds of data about what's in the environment. Now, in order for final gathering to make sense out of all that information, it uses something called point interpolation. That means that each point will average itself with neighboring points. So, by default, it's going to average, this point is going to average itself with 20 surrounding points. Averaging means it will smooth out the result. And that's what it's called, final gather result, in the end. So these points are going to start to blend and merge their information, kind of like the way that we have multiple pixels in the first lecture that were being sampled, and they had to average themselves together. They average themselves together with a filter. Well, in this case, we're averaging them together with not a filter, but with each other. So they're merging their color, they're merging their value information, they're approximating, averaging everything that's in here. That gives us a nice smooth result. So final gathering, shoots out points from the camera, doesn't care with what the camera cannot see. Each point shoots out rays, that's accuracy. They come back with information, points average themselves together, that's point interpolation. By default, it's set up for 0 secondary bounces. What does that mean? Well, when my red point here shoots up a ray and hits the ceiling, it does not bounce from the ceiling. It stops there and goes, okay, got the information, bringing it back. Now, if we turn on 1 secondary bounce, that means my point shoots up, hits the ceiling. Whatever angle it hits the ceiling with, it will then bounce back to another surface. So it could hit the floor, it could hit the table, it could hit further back on the floor, or it could hit you. Right? So what it's going to do is, that first surface it hits, it will come back with primary information. The second surface that it hits, it will come back with secondary information. So now what it's starting to do is getting more information from your environment. Right? Secondary bounces, you can go up as high as 4 or 5. And that's it. But each bounce comes back with more secondary information, and your scene starts to lose a little bit of contrast. Because now you're getting information from everywhere, it's going everywhere, and it's flattening your scene out little by little. So we generally keep this to 1, maybe 2, depending on what you need. Now, when you are working with final gathering uses all that information and creates what's called a map from it. That means it writes that information to a file. By default, that file is set to rebuild every time you hit the render button. That also means that in the future, when we get beyond just lighting, we get into materials. When you're done lighting, you can freeze your final gathering map, and it will reread the information that it got. So that means it doesn't have to calculate it. It can be quicker. So you can save a little bit of render time. So we finish lighting, we start working on materials, we freeze final gathering. You put materials in, you get your color in, then you unfreeze your map and run final gathering again so it can calculate all your color and all your reflectivity and surface properties. It saves a little bit of time. Now, we have 2 controls down here, primary and secondary diffuse bounces. As the name implies, primary bounce is going to be where your ray hits the first surface from your point. That is going to be primary. And that means that is the lion's share of the information. You have secondary, that is any additional bounces that it brings back. That means if you're getting too much secondary information, you can dial it down so it balances better. Now, until Maya 2014, this was the only set of controls we had for final gathering. We had to go in and we had to adjust everything individually. Okay, 2014, 2015, 2016 now, they've come up with a slider under the Quality tab called Indirect Diffuse Quality. This single slider will change all 3 of these parameters for you automatically. And the whole idea is for it to be easier and smarter for you to work with. This is a quality slider, basically. So 1 is production quality start point. For the size of our scenes, 1 is probably as much as you'll need. If you get into really big environments, 4K environments, 1080p, you might need to increase it. But for the size that we're working on, that should be more than enough quality. This also means that if you want quick feedback and you don't want final gathering to crank and waste a lot of quality time when you really don't need it, you want quick results, we can lower this to make the settings lower and final gathering work faster. So, this is down under the legacy options in the quality tab. The only time we really go down there now, since we have this slider, is to either add or subtract secondary bounces. Because that one slider does everything for you. And we can turn final gathering off and on. We don't need to go down to legacy. We can turn it off and on here under indirect diffuse GI mode. By default, brand new scene, it's going to be off. You can just turn it on to final gather, and you're set to go. All right, I'll give you a demo of that too. Any questions so far? Right, final gathering is kind of our gateway between no global illumination and full tilt global illumination. All right, so these are most of the talking points that I just did. So if you guys want to screenshot it or watch it on the archive, that's fine. It's pretty much everything I just went over. All right, now, before I get into doing the demo, let's do one last review of what we've got going on here. We've already talked about directional point spotlight. Now we're swapping over from the Maya area light to mental ray. So there are a couple things that changed. For example, what is the shadow softness control for a mental ray area light? Scale. Yeah, it's not a trick question. Remember, it behaves just like a regular area light. But you're absolutely right, scale. So the thing that did change is this, shadow quality. In Maya, shadow quality was what? Shadow ray, mental ray. High samples, thank you, yes. High samples. You can crank up your shadow rays to 1,000,000, billion, gajillion, and nothing will happen. High samples is the magic. Right, so anytime you're using a mental ray area light, high samples are the quality. All right. So I think I'm going to demo using the still life with a couple of objects because it's easy for me to be able to show linking and unlinking in that. And it's always fun to see more than one object. But the rabbit's perfectly fine also. Right, first thing you want to do, always set your project. All right, so there's my still life. I'm going to go into perspective because I like to kind of move around. All right, now, if you run across this where it shows up black, give it a second. It shouldn't come up with flip normals, but then again, it's Maya, so it gets ornery. Another thing you can do, in the viewport, make sure you've got viewport 2.0 turned on. That will give you a more accurate representation than the old legacy viewport. It's not going to be accurate as far as lighting goes, but it will be a little prettier. All right, so first thing I'm going to do is create an area light. And I'm going to use a basic Maya area light to start with. Now, if I want to manipulate this with a center of interest, what can I use? The T key, right? So I can pull up my area light. I'll move my center of interest into the center of the still life. All right, so this is almost 90 degrees from the camera. So I'm going to swing it around for the demo right now, just right around 45. Make sure mental ray is loaded. I am not doing anything else other than checking my scene to make sure in the render settings we're using legacy. We are. Good. All right, so good production start point is what? 2 for max samples. Do I need to adjust anti-aliasing contrast? Don't know until I render. If I got a lot of fine detail, I might. Gauss, that's my filter. I'm going to lower my filter size down to 2. Not a whole lot of difference, but there is some difference. And I'm going to render from the render cam. All right, final gathering is turned on for these scenes by default. I'm not going to address final gathering just yet. What I want to do is show you guys the difference between a Maya area light and a mental ray area light. All right, so this is a Maya area light, about 45 degrees left of the camera. It's elevated a little bit so it shoots down. The shadows aren't super long. Don't want it really long shadows because then it starts to overlap and hide parts of your subject. All right, so I'm going to keep image. And I want to turn this area light into a mental ray area light. So how can I do that? Well, mental ray is loaded because I just rendered with it. I'm going to go into the light attributes. Go down past the main set, go past shadows to mental ray. I want to expand mental ray. Under area light, there's a little switch there called use light shape. Once I turn that on, it is now a mental ray area light. And as such, will render a little bit differently. Notice the mental ray area light is softer looking. It's a little more physically accurate. That's a Maya area light, that's a mental ray area light. Notice the shadow here in this area behind the cup. It's a lot more hard, a lot more distinct, not quite as wrapping and forgiving. But here, this light kind of gets everywhere. Notice the hard edge on the cup. That edge is much softer with a mental ray area light. All right, does that make sense? All right, so when you guys are using a Maya area light today, convert it to a mental ray. That's going to be the first thing you do. Anytime we say area light, think mental ray. All right, now, another thing that you're going to want to do while you're working is not wait around for final gathering to crank and crank and crank. So what we can do is, down under advanced lighting, notice final gathering's turned on already for you. I'm going to take my indirect diffuse quality and I'm going to drop that down to 0.25. That is preview quality final gathering. What that will do is cut down on some of my render time. So it took 16 seconds to render. Let me re-render with the quality turned down for final gathering. It should take a little less time. All right, I shaved 5 seconds off my render. And there's really not a huge noticeable difference. Do you guys notice any difference? Not really. I mean, maybe if you looked at it really close, you'd be able to nitpick some of the little splotchiness in there. But when you're working for quick feedback, turn down that indirect diffuse quality. When you're ready for production quality, turn it back up to 1, you're set to go. Because you do want a higher quality for turn-in. All right, so 5 seconds is 5 seconds. Now notice it did not do anything for my shadows. That's a completely separate issue. Right now, normally to clean this up, we turn up shadow rays, right? Oh, won't take 10,000. Let's go. There we go. So 100,000 shadow rays. That should clean it up. No. Didn't have any effect on it at all. Remember, it's a mental ray area light. Shadow rays. Don't do diddly. My cleanup control, high samples. Now, when you're trying to figure out how much high sample to give it, pick an area that is the noisiest in your scene. Work on that as a small marqueed region. So for example, this backdrop right here. I'm going to marquee that. And when you're not sure, try doubling. Little better, not much. Getting better. I might try another area just to see what it looks like at 32. Still a little noisy. All right, so I've got final gathering turned down for quick feedback, but now I've got my area light, the high samples cranked up to get better quality. Now you still might notice on the projector some gritty noise here. That's because the projector is blowing up an image that's not, it's a VGA image. It's not even HDMI or DVI. So what you really want to go by is what does the screen look like on your computer at actual size. All right, so that looks like it cleaned it up pretty well. That behaves a lot more like natural light that we're used to seeing. All right, any questions so far? Does that make sense, first off? Anything not make sense? Anything not clear? So, mental ray area light's good. My area light's bad. Pretty simple. Put them in 2 categories. All right. Another thing I want to show you guys. And in order to do this, I need to move my area light so it's in the field of view of the camera. Because I want to be able to show you what the shapes do and what some other controls do. Right, so first thing I'm going to do is just move my area light here. Make sure it's in the field of view. And what I might do is scale it down so the whole light is visible for us. Right, so my light is more or less aimed at the camera. Now, if you remember from anybody who did the back area light exercise, you had that big negative space behind the area light, right? Area lights do not illuminate anything behind them. Only what's alongside and forward. Right, so I got this little rim thing going on here, mostly from the area light. Creating a little bit of illumination, but not much. What I want to do is show you what happens when you check on this visible switch at the bottom. Keep image, re-render it. That light then becomes visible to the camera. Now it looks like a softbox that you can actually see in the real world. That's the only thing it's doing, is making itself visible. This visible is mostly used for reflection, because there are plenty of cheaper ways to make a light appear to be visible, to make a light bulb appear to be glowing, than there are to make them out of area light. In fact, we will be using them when we get into environment lighting on Tuesday. We're going to start dealing with something called a surface shader, which is a self-illuminating material that gives the illusion that it's emanating light or emitting light. Very cheap, because it doesn't require lights. It just makes itself visible to the camera. All right, so making it visible, by default, we get a rectangle, courtesy of Maya, for the shape. Again, one of the added bonuses of a mental ray area light is you can change that to a disc. Disc, as the name implies, is going to make it look like it is elliptical or a sphere. Not sphere, but a circle. Almost looks like one of those lamps overhead that's got a hood on it. Except you'd be able to see the light bulb in here. All right, next shape that you have a choice of is a sphere. As the name implies, it turns that flat disc or flat rectangle into an object that illuminates on all sides. And it throws off light in an omnidirectional pattern. Just like a point light, except it's visible and it's physically accurate. Yeah, well, sort of like a sun, except this would be a lot softer than a sun. This would be kind of moonlight, or you ever see, anybody ever go to IKEA, see those big paper lanterns they have? Like paper balls. All right, put a bulb in there and it makes really nice, soft-looking light. That's what this is good for. They use that kind of lighting for interviews. Like it's very low wattage, low intensity, very soft, wraps around the face when they interview people. And they want it to appear to be very intimate. All right, so we've got a sphere. Next, you've got a cylinder. Cylinder, as the name implies, is a cylinder, kind of like a fluorescent bulb. But the difference is the ends are not capped. Who's a modeler? Anybody model? Okay. Who wants to be a modeler, I should say? All right, well, for the couple of you guys, does that bother you? Open cylinder? Yeah. you can't cap it off. So it's just going to eat at you all month. Just think of it as a big empty fluorescent bulb. Can't cap it off, sorry. I know it drives modelers crazy. Drove me crazy too when I started working with it, and I just, screw it. All right, now, there is something called custom, which the theory goes that you can take a piece of geometry, make it a light, and it will illuminate from the shape of that geometry. Doesn't work. It's called theory. In 2017, though, mental ray has emissive materials. That means that the material can be assigned to geometry, and it can then emit light like a light. And it will have all the attributes of an area light. So they've been promising custom for 15 years. And they're finally delivering it, but not the way they said they would. They're using emissive materials, which is the big thing. You get that in game engines too. All right, so you can play around with this all you want. There are tons of videos on the internet that claim they make it, but they don't. They basically use surface shaders and a bunch of tricks and make it look like it, but it's not a real mental ray area light. So the usable shapes: rectangle, disc, sphere, cylinder. Making it visible, that's basically all it's going to do. Make it visible to the camera. Now, if I turn off visibility, and I'm using the sphere, I'll just have a nice bright area up there that is not going to be visible to the camera. All right, any questions so far? Did I lose anybody? All right, let me show you light linking now. What I want to do is I'm going to use a light because I've got my candle here and it's kind of fading into the background. So I want to make a little bit of a rim light here just to separate candle from backdrop. Give it a little more sense of depth. Because here, all these shapes are more or less defined. But this one bothers me here. That just fades in way too much. Now, options for lights, what could I use? I got directional light. Would I use a directional light? Well, basically, you ask yourself, do I need the sun? No, that'd be overkill. Okay, but what light type? Not position. I could use a front light, but I'm trying to figure out where do I start? Like if I want to use a rim light, what are my choices? I've got directional light, point light, spotlight, area, another area light. Which one? Spotlight? Why? Okay, can focus on the shape, right? Can make it big or small. I can change the penumbra on it. That's a good choice because it acts like a projector. I can pretty much guarantee where the light's going to go. I might be able to use a point light, but I would probably have to unlink it from everything else because that point light's going to shine everywhere. And not only is it going to hit my candle, it's going to hit the backdrop, it's going to hit the geometry here, and I don't necessarily want that to happen. With a spotlight, I can aim it and pretty much just get it to hit where I want it. So yeah, that would be my choice because in photography, that's probably what they're going to use for a rim light or a backlight. All right, so what I'm going to do, go into perspective. I'm going to create a spotlight, Again, a couple things I can do with my spotlight that I can't do with the point or the area. Let's look through it like a camera. Because it acts like a projector, I can treat it like a camera. So I can use the center of interest and I can line it up and pretty much guarantee where it's going to go. Or I could select the light, go to panels, look through selected, and I can just kind of spin around and I can zoom in on the area that I want it to affect. All right, that might be a little close, but it'll work. Another thing I could do is if I'm looking through it, I can also dial down my cone angle. And notice in my view from the spotlight, it scales that cone angle for me. So now if I render this out, a little overkill. So this might be a really good example of, do I really want my kick light, rim light, backlight, whatever you want to call it. Right now it's not acting like either one. Do I really want it to influence my backdrop? No, because it's creating extra shadow and extra light. That is definitely not the subject that I want to focus on. So what I can do is go under Windows, Relationship Editors, Light Linking. I can go Light Centric, which shows me my lights on the left, geometry on the right. If I click on a light, it shows me everything it's linked up to. I can also go to Windows, Relationship Editors, Light Linking, Object Centric. And now if I click on an object, it will show me what lights are linked up to it. Personally, I prefer Light Centric, just because I've gotten used to it. I like the fact that I can go Spotlight. I want to unlink it from the backdrop. So I select Spotlight, come over to Backdrop, left click once, it's gone. And by gone, I mean it no longer will pay attention or emit light on the backdrop. Completely ignores it. All right, I'm going to turn down my area light settings a little bit so it doesn't kill the render time too much. Now, if I want to link it back up again, all I have to do is go into Relationship Editor, select the spotlight, click on that, so it highlights again, and when I re-render it, it is linked back up. Now, some of the issues if you don't have Service Pack 6 are, you click on it, it looks like it's linked up, but when you render it, it's not. Right, didn't change anything other than the fact now that I've got now, notice that nothing is linked up to it. It's not illuminating anything else. That's because I clicked on the group and unlinked the group. So it's ignoring the candle. That's something you have to be careful of. If you accidentally uncheck the group, the main group, it will completely ignore everything. Another danger. Notice the area lights linked up to everything. That includes materials. One thing you want to make sure that you are linked up to is all the materials. Because if you accidentally unlink everything from the materials, watch what happens to your scene. Pretty much everything had the material X assigned to it. The area light is now ignoring everything the material had assigned to it. Don't accidentally unlink materials. Keep them linked up. You will drive yourself crazy. Only unlink lights from geometry. Much easier to troubleshoot. Right, does that make sense? Anybody have any questions? Light linking. Anything not clear? All right, so light linking, that's all fine and well. The only thing I would do now is kind of dial down how my spotlight's working. Can add a little penumbra to soften the edge a little bit. Add a little bit of drop off so it's not quite so bright. Maybe adjust the decay a little bit where it becomes useful. Okay, so I deleted my lights in my scene, and I want to talk about final gathering real quick. All right, now, there are a couple things you can do in final gathering to visualize how it works. One of them, and actually both of them are under the render settings, under quality, under legacy options. Go down under final gathering, and you go down under final gathering map. There are two ways to visualize it. One is called enable map visualizer. Now what does that do? If I hit the render button, even though I don't have any lights in my scene, nothing happened here. Well, turn it on. There we go. Enable map visualizer and then hit render. But it didn't render anything, but final gathering did shoot points out. And those points are visible in the render view. Notice it shoots out points based on the camera. Doesn't really care what's going on behind the camera. And it creates a little node for you in the outliner called map viz. That lets you visualize in hardware view, in the viewport, where final gathering is shooting points out, how dense are the points, where's the location of the points. Okay, it's just pure visualization. Doesn't really have anything to do with final gathering. In fact, I can move this around if I want. I can pull it over here. All right, all it's doing is giving you a visualization that you can work with. Now, if you turn it off and re-render it, you would think, good, it's going to go away. It'll clean up for me. No. It's there forever unless you hit delete. All right, so that's one way you can visualize it in the viewport. The other way we can visualize it is if we can actually see it in the render. Right now, no lights in the scene, final gathering's turned on. Final gathering has nothing to get information from. Because each one of those points is shooting out rays. What are those rays hitting? Anything? Is there anything out past the backdrop? No, it's the black, empty Maya nothingness. Final gathering's got nothing to grab. Now, what we could do is, and we'll be doing this starting next lecture, is we will be creating what's called image-based lighting sphere. Did you guys do this in 3DF at all? With Arnold? No? All right, so that's under scene. And there's a big button called image-based lighting. Now, I'm not going to plug an image in here. I'm actually just going to make it a texture. So, image-based lighting by default is a big cage that contains nothing. Unless you tell it that it's either a texture or it's got an image in it. So I'm going to change it to texture. By default, my texture is what color? Black. If I render it out, final gathering is not going to be able to grab anything. Black is equal to what number in Maya? Anybody know? 0. Yep, 0. So it's got 0 value information to bring back. However, if I turn that color to white and render out with no lights in my scene, now final gathering can grab value information from that sphere, bring it back into the environment. Now notice it looks like it's got a disease. That's because I've got final gathering settings turned down really low. What you're looking at is all the splotchy points, and there's not enough points there for it to be able to interpolate and smooth out. But it gives you soft, light looking information. Very soft shadows. The shadows generally are pretty clean. Doesn't look like it on there because you've got all the banding from projector. But here it's pretty clean. Except for all the splotchy noise. And again, that splotchy noise is caused by this right here. If I put that back to my default of 1 and re-render, now final gathering can add a lot more points and smooth them out a lot better, and it will make the whole scene look better. All right, we're going to get into more final gathering next lecture. We're also going to get into adding images into the IBL, the image-based lighting sphere. We're actually going to be using high dynamic range images. That's going to help add a little bit of indirect illumination into our environment. We're going to be starting with an indoor environment, then we'll work our way to an outdoor. But today, all about small scale, multiple light scene. All right, so here is the reference that we give for you guys. So if you've got your project set, go up a couple levels to the reference folder. There's the rabbit. All right, so the rabbit 01, that's the key light. That's what you want to load in if you're going to work on the rabbit. That is just the mental ray area light key light. Light's coming from what side? The right. Yep. Your job is going to be to figure out how big is the light. Start with the original scale of 1. Work your way up or down if needed. You're also going to be working with intensity, decay. Decay is going to be an issue too because is it as bright here as it is here? No. That means the light is decayed. Right, so that's your key light. Then you're going to bring in the fill light. Fill light's coming from what direction? Left side. Very low intensity. Remember, when you're working with fill lights, you can always start with the fill light at half power. Whatever the key light is, fill light can be half. In this case, it may be lower, it may be higher. So, fill light, match that up. Then there is the rim light. Rim light. Is the rim light hitting the backdrop? What does that tell you? I heard it. Somebody said it. Light linking. You want to unlink it from the backdrop because you don't want it broadcasting light down here. Also, the fact that I've got some light sneaking around the side tells you shadows are turned off in this light. Sneaky. Okay, so key light's going to be mental ray area light. Fill light's going to be mental ray area light. Choice for this light is going to be a spotlight because you can aim it precisely where you want it. It's not going to illuminate in all directions and give you areas that you don't want. You can see it's directional. It's coming from probably, if you look at that compass, 135 left behind the subject to the right. Then when you're all done, and basically what you're going to do is make a light, get it to look good, then you're going to hide that light, load in your next reference, make another light, get the fill light to look good, hide that light, work on the rim light. Then when you're all done, each light looks good by itself, you turn them all on. Lighting is additive, and in the end, that should be your final result, or something close to it. Okay, some milestones, not milestones, but landmark features that you can kind of go for when working with the key light. Tail shadow is one of them. That'll help you. And also, if you get the tail shadow right, that will usually get the illumination here, and also the way the shadow hits or comes from the front paw. It'll also give you kind of an idea of where the shadow's going. So this shadow is it's very soft, but it's more or less going in that direction. It's not parallel to the ground. All right, with the other still life, you get the same thing. Here's your key light. Key light's coming from which direction? Left. So opposite side of the rabbit this time. Coming from the left, is it as bright here on the left side as it is on the right? They the same intensity? No, so that tells you probably decay. Again, you want to try and look at light, the way it hits the cup here, shadows from the fruit and the bowl. Those are going to help you as far as, do I have my light positioned correctly? Remember, load your reference in. All right, so fill light. Fill light's coming from which side? From the right side over here. Because the right side of the objects are illuminated, left side's in shadow. Again, this is going to be decay. Okay, we have a backlight that creates that nice little halo right behind the bowl and the fruit. You could do that with a couple of different lights. What would one of them be? Point light, that might work, absolutely. Because it shines in all directions and you can control it with decay. What else could you use? Anybody? Yeah, we could use a spotlight. Right, when you're all done, turn them all on. There's your final. Okay, as far as templates go, there's one template. You just change the reference you're going to use. If you're working on the rabbit, that's on by default, the Cornell rabbit. Turn off the rabbit, you have the still life, you're set to go. When you do the composition of your choice, the portrait or whatever you choose to do with multiple lights, you're going to drop that in up here, drop your render down here. All right, so for your lighting, you're going to give us intensity information, decay information. You're dealing with a mental ray area light, so high samples. Rim or backlight, what's the intensity? What's the decay? Put the scene name up here. Is it still life? Is it the Cornell rabbit? All right, any questions? Okay. Go to lunch. We're actually ending on time today. So come back at 11:45.